Have done all his field work in the Midwest, except for one season each in Israel, England, and Mexico. So Professor Green specializes in North American archaeology, ethnohistory, and ethnology. Currently studying woodland communities between 1,000 and 2,000 years ago in the Mississippi River Valley. Research has been funded by a number of sources, including Nation, Cultural Resources Division, the NSF, National Science Foundation, and Dr. Green is a former director of the Office of the State Archaeologist at the University of Iowa. Publishes widely in fields such as environmental archaeology, museum studies, of course, and native North American culture. Please join me in welcoming Dr. Green to our campus this afternoon for his talk is entitled Gast or Gast Farm, the Archaeology of People and Place in the Mississippi.
Thanks, Paul. Thanks to both the department and the WAS for inviting me here. I'm glad to be here, and happy holiday weekend to everybody. I will try to keep this to reasonable length, 45 minutes or so, and then plenty of time for questions, I hope, afterward. And I hope the slides are visible for everybody. I'm going to stay here near the microphone because after a week, as I said to Rob, of shouting at students all week, my throat, I have a number of research questions. Every archaeologist likes to start out with a number of research questions. These weren't necessarily the ones that we began the project with 28 years ago, but these are the ones that have evolved over time. And I'm going to discuss them in general terms. I'm not really going to come back and try to address each one specifically, but you can keep these in mind as we go through the discussion of Gast Farm. We're interested in how people organize their communities and how the archaeological record reflects this organization or several types of organizations. And we're interested in how communities change over time or remain stable. And we're interested in how communities and their inhabitants, of course, interact with environments, natural environments and human environments as well. And so our case study is this place known as Gast Farm in the Mississippi River Valley in southeast Iowa. And this map shows its location in relation to a number of other well-known sites, if you're in the club, that is, of Midwestern woodland archaeologists. And we'll see a couple of illustrations of comparisons between what we find at Gast Farm and what we find at other sites, all the way from the Millville site in southwestern Wisconsin all the way down to the Camp Mounds in west central Illinois. And we'll also be talking about what we call the Havana culture, or the Havana variant, and the Weaver culture, or the Weaver variant. And this map is just meant to show you where those names come from. Those are archaeological sites in the central Illinois River Valley. The Havana site in the city of Havana, Illinois, and the Weaver site just downriver, just upriver a little bit. So this is where we are spatially, right in the heart of the central Midwest, the Prairie Peninsula, right in the Mississippi River Valley. The locality that we're dealing with is called the Muscatine Island locality, part of the Mississippi River. It's not really an island, but if you can follow the cursor around, there's this thing called Muscatine Slough, which is an old channel. It's an abandoned channel of the Mississippi River, and so that forms the western boundary of this very large complex of terraces and alluvial fans called Muscatine Island. So this area here is Muscatine Island on the west side of the Mississippi River Valley. The city of Muscatine here, the bustling metropolis of Wapello down here, and Gast Farm situated right here within the Muscatine Island locality. And here's what it looks like with a little bit of topography added to it. So the city of Muscatine up at the north, and the area here between Muscatine Slough and the Mississippi River. So it's a really rich environment. Here's a map that depicts the vegetation and wetland complexes as observed in the early 19th century by the early American General Land Office surveyors who were through the area. And you'll notice that there is a real nice mosaic, a mixture of prairie, of dry prairie, as well as wet prairie, marshes, rivers, backwaters, and a lot of timber as well. It's one of the richest spots you could hope to find as far as natural resource abundance and diversity in the Mississippi River Valley. Now I'm going to be talking a lot about different time periods, and there's some, it can become a complex terminological thicket. I'm going to try to keep it as simple as possible. Starting on the left side, we have middle woodland groups and we have late woodland groups, and we're just going to use the year 300 AD to divide the two, all right? Middle woodland groups in this region, we generally tend to lump under Havana. Like I said, the Havana culture, the Havana variant, all right? Late woodland, after 300 AD, Weaver. The best way to understand this and to keep this in mind as I switch back and forth between middle woodland, late woodland, Havana, Weaver. Havana starts with an H. It comes before W in the alphabet. So Havana comes before Weaver. That's all you need to know here. Havana is older than Weaver. Well, that's not all you need to know. A big part of the Havana variant, for about 200, 250 years, it was occupied by what we call the Hopewell network, the Hopewell interaction sphere. This was a system that connected many groups throughout eastern North America between about 50 BC up to about 200 AD in Illinois and Iowa, and a little bit later in Ohio. So that's what we refer to when we're talking about Hopewell, and these are some of the phase names. We're not going to be talking about phases per se. But so this sets up the basic temporal framework for you. We're interested in communities that were built and occupied by people in these different time periods. What were Havana communities like? What were Weaver communities like? How are they the same? How are they different? Why did they change? Now we've used a number of research methods to try to address these questions. And since this is a 28-year-long project, we've had an opportunity to use many, many of these different methods. So we started by studying existing collections. We did our own controlled surface collections on these plowed fields. We employed geologists to assist with understanding the stratigraphy, the geomorphology of these sites. Of course, then we conducted excavations with field schools, and then on with dating, analysis, and more recently, digitization of aerial photos, use of GIS, Geographic Information Systems, and some of the other technologies, including one that I'm going to emphasize today, which is geophysical survey, magnetic radiometry, in order to see beneath the surface without excavating. And then finally, we've begun experimenting also with various forms of thermal imaging, using drones to understand features on the basis of soil temperature and vegetation temperature, things like that. None of this would have been possible without Dan Gast, who was the landowner when we started working on the site. Dan owned the site for most of his lifetime. Part of the site is still in his family. He amassed an amazing collection of artifacts that he collected off the surface, and he often let other people come in to collect as well. So in southeast Iowa and adjacent areas in Illinois, there are traditions of people spending weekends hunting for artifacts at Gast Farm. You can see part of his collection on the lower left, just some of the stone tools, a pottery vessel that he found in the ditch leading up to his house along the lane, and then that pipe in the middle, the two copper axes on the upper right, and the sheets of mica on the lower right. Those were all found in a mound that once existed on the surface of the Gast Farm site. It was not very well documented. Local people talk about a mound being maybe 100 feet in diameter, 10 feet high. And Dan said that in the 1950s, he was unable to get any archaeologists interested in it because it couldn't be a real Indian mound because all Indian mounds were on the bluff top, is what he said, that they said. And this was in a valley rather than the bluff top. So he went ahead and leveled it, and during the process of leveling it, he found these interesting Hopewell artifacts, the pipe, the copper, the mica. So that continued to keep people interested in the site through the years. The site itself occupies pretty much the entire central field of this image, and it's about a 30-acre field. On the right-hand side, you see a channel, the channel of Muscatine Slough. Remember that old channel of the Mississippi River. And on the far left, the white are the high elevation bluffs, the 200-foot high bluffs that border the Mississippi River Valley. And in between, you see elevation changes. And it's actually fairly gradual. It's not as dramatic as this image implies. But you'll see it's an alluvial fan. It's built up by sediment washed down from the uplands in these little channels and deposited here, and then it kind of thins out as it moves to the east. So alluvial fans are wonderful places for people to live in because they are situated high enough above the main valley so that they escape flooding from the river. And if you're not right along one of these channels, then you escape flooding from the uplands as well. And so people throughout the Mississippi River Valley have preferentially set their settlements on alluvial fans throughout prehistory. One of the ways to understand how these fans were formed is to drill them. And we've also dug big trenches and through our regular excavations as well. But the quickest way to get an idea of the stratigraphy of these fans, how did they build up through time, is to core them. And so Art Bettis, who was with the Iowa Geological Survey at the time and now in the geoscience department at the University of Iowa, had already done a lot of coring in this part of the Mississippi River Valley and was already developing a real good understanding of landform evolution and landform change through time. So the drills that he was drilling into the fan revealed this sort of classic layer cake stratigraphy. Each of these lines with these little squiggly lines underneath them is a stable soil that's been buried. And this, of course, is a lot of vertical exaggeration here. But this is the stable soil at about 6,000 years ago. This is the stable soil at about 3,000 years ago. And the surface, fortunately for us, has been relatively stable for about the past 2,000 years. So we have a lot of buildup over about a 10,000-year period and relative stability near the top. So these fans are great places to study early cultures, like archaic cultures. They're very well preserved beneath them. And if you've heard of sites like the Coster site in the lower Illinois River Valley, that is a deeply buried series of occupations within an alluvial fan. Well, we're interested in what's closer to the surface on this site. And like I said, we're fortunate that deposition on this site basically ended a little over 2,000 years ago. So the communities that we're interested in from between 1,000 and 2,000 years ago are situated fairly close to the surface. And that allowed us to begin field work by doing controlled surface collections. We gridded off the entire site, all 30 acres in 10 by 10 meter squares. We collected over 1,600 of these squares. Everything that we could find except what we thought was rough stone, rough rock, fire-cracked rock, things like that. But everything else, thousands of potsherds, thousands of tools, flint tools, groundstone tools, thousands of animal bones, all mapped within each of these 10 by 10 meter units. And this was back in the day when everything was plowed down and nice and flat and washed nice and flat. And these days, as you'll see in a moment, we don't have these kinds of surface conditions anymore. This is the way the field looked at the time that we were doing the surface collections. These were aerial photos that I took while circling over the site in 1990 as we were just completing our surface collection. So at the top is a view to the north-northwest. Here is Muscatine Slough going all in. Here's the rest of Muscatine Island here. So this is the field that we collected. And this is a view of the field from the west looking east. And once again, here's the slough. So you can always orient yourself by the farmhouse, which is at the northwest corner of the field, and by this road, which is at the south edge of the field. And right away, you can probably see a couple of things. There's this big black kind of circular area in the western end of the site. There's a white spot here and some other white spots here, and another kind of dark area here, and then of course this very dark area near the slough. So you'll see these over and over again. So I took a series of 20 or 25 aerial photos circling over the site, and then last year we got with our friends at the University of Arkansas, and I asked them, well, can you somehow magically turn these oblique, angled aerial photos into a vertical aerial photo that we can use as the base for our geographic information system. Can you, in effect, georeference my oblique air photos? And they said, well, I don't know. Let's see, your photos might not be good enough. Well, turned out they were good enough, and there are a number of points. You can see there's a dozen different points that can be identified in multiple photographs, and it was possible to georeference. And so every part of the field that's in blue here has been georeferenced and is used now as a base for our geographic information system. This shows exactly where I was and how high I was in the plane as I was circling over the site and what angle I was taking the photo at. And here are the positions on the ground where I was taking those pictures. And here's a digital elevation model that's based on these air photos that I took 28 years ago circling over the site. I could retire happy right now. It's amazing. So this is the resulting image, right? We can still see that kind of black area over here and these white spots in the middle. So here's one way to interpret it. You could say, well, those dark spots could be midden or organically enriched soil from habitation, another one here. That white area might be a mound, because remember, Dan leveled a mound in the 1950s. And these things, wow, these kind of have a geometric kind of look to them, these other white splotches, and we thought, well, maybe they're earthworks of some kind. And then this very dark area here you can just ignore because that's dredged material that came out of the slough. And also, you see all these vertical lines exactly 10 meters apart. So as we were walking back and forth between the grid lines, as we were collecting them, we created those paths on the ground. And this is why I like using this map rather than other aerial photos. You know, we have hundreds of vertical aerial photos that can be georeferenced, but this is from the exact time that we were doing the controlled surface collection. And it's from photos that I took also. So this is our base map now. Here's an air photo. This is also based on oblique air photos taken by a friend of ours in Illinois, Farrell Anderson. He was using infrared film in the 1970s, and it shows similar features. And we also had the photo turned from oblique to an ortho-rectified, georeferenced vertical image. It shows the same kind of things. Oh, one thing to kind of note is that we have this dark area here, but then it's kind of light at the north end. And we figured that that might be relatively recently deposited sediment coming down from the uplands, because the alluvial fan, that part of the alluvial fan was still building up very slightly. And so we're thinking, well, maybe that recent deposition might be obscuring parts of that portion of the archaeological site. Okay, well, what did we find in our controlled surface collection? Well, over at the eastern end of the site was middle woodland, Hopewell material. This is classic, what archaeologists like to call high church Hopewell material, the fancy, decorated, thin, very well-made Hopewell material. It's a horizon marker. It's very diagnostic, very distinctive of the period from, you know, right around 50 BC, 50 AD, up to maybe 100, 150 AD, not too much later than that. And we also found a lot of the utilitarian pottery, sort of the everyday material made by people at that time, Havana ware, of course, Havana variant, middle woodland, right around that same time period. Nice variety of different styles of decoration that fit right into this time period. And the stone tools made by these people, again, classic high church Havana material, these nice wide, broad Snyder's points, which were for spears or large darts, and hundreds of these, what we call lamellar blades, flake blades, ribbon flake blades, kind of like little razors. Many of these are made of local chert, local flint. They didn't have to go more than a day's walk, but some of them were found from what we call semi-local material, like this is Moline chert from the Quad Cities area, a couple days walk maybe, and then some material from southern Illinois as well. So there's a small amount of exotic material as well as the local stuff. And when we map out where we find all this middle woodland material, this early pottery especially, and then we kind of fuzz it out using some computer magic, we get this distribution map. This is where we found on the site the middle woodland Havana material. So it's all concentrated in the eastern end of the site. Now, we also found thousands of pieces of pottery of Weaverware, which of course is diagnostic of the late Woodland Weaver variant. This is some of the plainest pottery ever made in the world. When we're fortunate, there are little notches near the lip, on the outside of the lip usually, but there's almost never any other kind of decoration. But the pottery is a lot thinner and it's very distinctive, so it's very easy to separate it out in most cases from the other stuff. And the stone tools are also very easy to separate from the earlier stuff. They're not making that very broad corner-notched style of point anymore. They're making these expanding stem points. And once again, these are darts rather than arrows, and they're using mostly local material, but with some imported stuff like this Southern Illinois material here, but mostly local. And all of that pottery, all of that Weaver pottery was concentrated over at the western end of the site. So we really don't have any overlap between the main occupations, this was new to us at the time. Nobody really knew because all you'd seen was a room full of pottery. And so this was very important for us to separate out the two different occupations. So armed with that information, a number of University of Iowa field schools and Iowa Archaeological Society volunteer excavations were conducted on the site, 1991 through 1994. And we had fairly large crews out there, and we thought we were excavating a lot of ground. It did not amount to more than a fraction of 1% of the site areas. So if this map is clear enough, I don't know if you can tell, these are 10-meter blocks, and within the 10-meter blocks, you can see little white areas, 2 by 2 meter squares, 1 by 1 meter squares. Those are the actual areas excavated in the western part of the site. And over here in the eastern part of the site, these are, again, a series of 1 by 1 meter and 2 by 2 meter squares. So really only a small fraction of the site. And here's how they line up according to the Middle Woodland community and the Late Woodland community. So here we tried to sample different parts of the community because we'd already sort of detected that it was a circular shape, maybe with a central open space. We had no idea what kind of layout this community would have, so we just decided to kind of dig a couple of transects across it and got some interesting material. We got a couple of dozen features identified here, well over 100 features identified here, just in the tiny areas that we were able to excavate. These are some of the units. On the right, you'll see one of the Weaver late woodland features. This is, we call this our acorn disaster, because every one of those tiny little black rounded bits that you see in there is a burnt acorn. And this is about the only place on the entire site that we found any acorn shells. If we hadn't have found this, we wouldn't have known that they paid any attention to acorns at all. Here's our acorn disaster. They might have been leaching or parching them or something and had an accident and had to bury them before the whole village burned down. That's our story anyway. And then over on the left, you can see this is the area that was plowed. This is our plow zone. This is an area of organic enrichment, midden, so to speak, and the subsoil here, the features show up in the subsoil. And if we dig deep enough, we get into that 3,000-year-old archaic soil, that buried soil, which we tried to avoid in most of the units. Okay, a lot of collection, some digging, and fortunately we had some really excellent students at the University of Iowa, and we came up with a number of honors theses and master's theses and these 3 dissertations. The one by Mike Dunn on the plant remains, the one by Rebecca Johnson on the pottery, the Middle Woodland pottery especially, and one by Margot Neverett on the animal remains. And unfortunately, that's kind of where things stayed for about 15 years. I always wanted to go back. I always wanted to do more work on it. I always wanted to run more radiocarbon dates too. So I was fortunate to be able to start doing that, to get back into the collections a couple years ago and to develop sort of a revised research plan. How can we put this together, synthesize this information, begin to address some new questions, and use some new technology to understand a little bit more about the communities at this site. The radiocarbon dates go all the way from the geological dates, from the deep cores, to a couple of good late archaic dates. There's an early woodland one I'll talk about. A whole series of dates from the Havana community, a whole series of dates from the Weaver, and then one from the very latest late woodland occupation. So let me warn you about radiocarbon dates. Well, first, the good news. We decided to submit paired samples to different labs in a couple of cases just to see how we were doing. So these two, you see the brackets here, from two different labs. They're only a few years apart. They were dated different materials, different types of nutshell from the same context, and they're statistically identical. Yay, that's great. Okay, the same thing down here. And here we were using animal bone, the collagen from unburned animal bone, and comparing that to a sample that was sort of a combination of wood and nutshell. And once again, almost identical, statistically indistinguishable. So yay, bone collagen can work as well. Now, there are a couple of red X's here. So what does that mean? These are dates that came out 400 years more recent than they should have. We were really worried about that. They're both on calcined bone, which might be part of the problem. They're both from the same lab, which might be part of the problem, but we also got a couple of good dates from that lab. So the paired dates, this one down here, this early Woodland date, is from the same context as this date. And this 2055 BP is from the same context as this 1653. These are 400 years apart. So I don't trust dates on calcined bone anymore. There was an article in American Antiquity last year by the guy who worked on the Kennewick Man, Jim Chatters, and some of his friends at this lab, this DAMS lab, who said, you know, calcined bone can really work. And they ran a number of paired samples, and it worked for them. It didn't work for me. That's all I can say. So let's just focus on the Woodland dates. These are the Havana Middle Woodland dates. These are the Weaver Late Woodland dates. The Weaver dates are really tight. There might be a slightly later subsequent occupation, but we have a very tight clustering of dates. Even though none of these are AMS dates, they all have large error, plus or minus 70. But I think we've got a very good tight occupation right around 400 AD. Middle Woodland, I'm not so sure about yet, and this ends up being a very important issue. Was it a single, relatively short-term occupation? Was it reoccupied periodically over 150 or 200 years? I'm not sure yet. And somewhere in this room, there has got to be a knowledgeable, statistically savvy grad student or faculty member who can run some Bayesian tests or whatever you do these days in order to find out whether we're dealing with what the likelihood is of this being single occupation, multiple occupations, et cetera, et cetera. So see me afterward, and you'll get fame and glory when you help us figure out answers to these questions. All right.
Tony Cruz's email.
Who's that?
Tony Cruz.
All right. I'll go with anyone. Let's look briefly at what some of our students discovered as they were writing their dissertations. This is a comparison of the animal bone between the two components, the Havana, the Middle Woodland, the Weaver, the Late Woodland. A couple of main differences up in this upper graph. This is the one to pay attention to. On a proportional basis, the earlier occupation used more than twice as much deer, but only half as much fish and twice as much turtle. It's kind of interesting. The turtle bones, I'm not sure that had a real subsistence focus to it, because in the Middle Woodland community, they were using a lot of the turtle elements as tools and containers and ornaments. So a lot of the turtle utilization might not have been strictly for food. They might have had many other uses for it. But there's an interesting distinction, a dichotomy really, between a lot of use of fish later on, less use of deer, and just the opposite in the earlier period. So whether that has implications regarding the seasons of occupation, the sources of protein, the allocation of labor, all kinds of possibilities are going on there. And then looking at the plant remains too, there's a real interesting difference not only at this site, but throughout the Midwest between Havana plant use, Middle Woodland, and Weaver in the early Late Woodland. And just looking at the nutshell to begin with, which is what these are, early on, there's not a great deal of difference between the different types of nuts that are utilized. You might not think this is important necessarily, but it does have some really interesting implications because it's a regional pattern. There are very similar amounts of hickory, hazel, and walnut. This is really a large amount of hazelnut utilization. And in the Midwest, that's found almost entirely and exclusively in the middle woodland, which has led people to believe, or to hypothesize at least, that this focus on hazelnut utilization might have actually been as a result of some form of encouragement or cultivation of hazel. And that has all kinds of implications, again, regarding seasonality and labor allocation. But the key thing for us here is that it does fit into this region-wide middle woodland pattern of very extensive hazelnut utilization. Now, looking at the late woodland, if we get rid of this bar here, that's the acorn disaster, okay? If we get rid of the acorn disaster, then this is all the acorns that were used at the site. And instead, we have this amazing focus on hickory nut utilization instead. And this, once again, is a pattern that we see throughout much of the Midwest, a focus on hickory nut and a diminution of interest in the other forms of nutshell. Seasonal implications, task utilization implications, a variety of things possibly going on there. But let us focus instead on the small seeds, which I think are just as interesting, if not more so, than the nutshell. And I've put little green stars next to the seeds of plants that ripen in the spring, in May through about mid-June. And there's two main types, a plant called maygrass and a plant called little barley. In the middle woodland in the Havana, there's some use of them, but it's not the dominant use. And so it does appear that there's occupation of the site in the spring, but most of the diagnostic small seeds are from plants like this Chenopodium goosefoot, which ripen late in the summer and in the fall. And there are other fall ripening plants as well. Well, later on, the emphasis, the majority of the ripening, of the early ripening seeds, the majority of the seeds are the early ripening seeds, okay? The little barley and the maygrass, which is kind of interesting because obviously the majority of the nutshell and probably the majority of the fish are coming in the summer and the fall. So we've got a really extensive, probably year-round occupation going on in the late woodland, and possibly more sporadic in the middle woodland. And then looking at the faunal evidence as well, we're not sure that we really do have wintertime, year-round occupation in the Havana community. We think there might have been, but it's pretty clear that that was the case in the Weaver, in the late woodland community. Now, this has implications for a number of things that we'll get to when we talk about community structure, et cetera. Well, one of the things that new technology allows us to do is to be a little more precise about mapping, elevation mapping, and coming up with digital elevation models. Each of these little red dots here is a return from a laser beam that was shot at the site from an aircraft in 2009, producing what we call LiDAR, the laser-derived elevation models. And so that allows us to develop these kinds of models. This is a vertical exaggeration once again. And if we're looking for things on the site like, are there any traces of that mound that people had talked about in the 1950s? Well, maybe these little bumps might exist in reality, and one of them is kind of close to where that mound apparently was. But you see that most of the terrain, most of the topography on the site is just plow furrows. I mean, we're looking at topographic elevation differences here of like 5 centimeters. So we don't really know whether that is a remnant of a mound or not, but it's in approximately the right location. And we were hoping to find evidence possibly of earthworks. Remember those other white stripes on the site? And we were thinking, wow, maybe the LiDAR can pick up some traces of earthworks. And we really couldn't detect, as much as we wanted to find them, we really couldn't detect them on this. And so we decided to do some geophysical survey. And this is using, we decided on magnetic radiometry, which detects magnetic differences in the soil at the nanotesla level. Okay, and these are really highly sensitive instruments that will allow you to understand what kinds of features exist beneath the soil. You get high magnetism, where you have cultural features filled with topsoil and other organically enriched material. You have low magnetism when you have subsoil and other less organic material. That's kind of the simplest way to put it. So this was in the fall of 2016. Adam Weaverware, who is the gentleman in the top picture, and Steve DeVore, who is in the bottom picture, are archaeologists with the National Park Service Midwest Archaeological Center in Lincoln, Nebraska, specialists in geophysical survey and remote sensing. They came out to work at the site with us, basically for free. The Park Service donated their time. We had to come up with the expenses for the trip from grants, but because this site has the potential to be designated a National Historic Landmark, the program that the National Park Service runs allows them to do this kind of work, encourages them to do this kind of work. So we really wanted to, on the basis of the surface collections, the earlier work, the excavations that have been done, we really wanted to learn more about the community organization, what they look like beneath the surface. And this was the most cost-efficient way to do that. This is the map. This is basically the unretouched map of the geophysical survey results after about 8 days of 2 people running the instruments, 3 other people running around with surveying and laying out stakes and ropes. So what do we see here? Well, all of the little pockmarks and everything that you see on this map is an anomaly of some kind. It's a magnetic anomaly of some sort. Cultural anomalies would be concentrated here and here. These would be pit features for the most part, which were kind of amazing when they started showing up as we were downloading the data at lunch every day. And then Adam asked me, well, did they build big circular earth lodges here? And I said, no, of course not. You know, that's out on the plains. Here they built big circular mounds, and turns out, looks like we've got about 7 of these big circular mounds in the middle of the site. This big one is approximately where the large mound from the 1950s was located, but none of these others had been documented. So I had 2 Howard Carter moments as I was looking at this data in the field. Howard Carter, right, who's King Tut's tomb, you know, well, I see wonderful things. The first was, this appears to be a planned oval community with a central open area. We already knew this was an oval community with a central open area based on the previous work. But this was Howard Carter moment number 1, and these mounds were Howard Carter moment number 2. This is another way to look at it, just reversing the image. So instead of the anomalies being dark, they're light. The high magnetic anomalies here are light rather than dark, and maybe this helps you visualize the cultural features a little better. The late woodland community over here, the middle woodland over here, and a few traces of the mounds in the middle. So let's watch it fade. So here's the magnetic data superimposed over a recent air photo. So you can see how these line up in terms of relation to the farmhouse, but also in relation to the channels. You see there are these channels. This one is filled with subsoil. This one is filled with more topsoil. And we were wondering if these were cultural features or not. No, those are natural channels. And you can see that as we sort of fade them out. And just before we totally fade away, you might even see a tiny trace of this mound and maybe this mound showing up in the vegetation. And when the thermal data, which I'm not going to show you, also hints at the fact that there might be traces of the mounds that can be detected in the vegetation. So, and there they go. So if you kind of know what to look for, well, wow, maybe there is a trace of that mound right there. Otherwise, you know, you wouldn't know it. So there it is again. Let's fade in this time. Okay. So one of our big questions is, well, is this really a Havana Hopewell community, or is this a series of smaller individual homesteads that were occupied over many years that just happened to end up in a 140 by 120 meter oval shape with a vacant center, which is possible. So we decided to just focus on the most distinct anomalies. There were thousands of anomalies, thousands of cultural features. These are just the ones that are by far the highest threshold, greater than 25 nanoteslas. So you can see the layout here, middle woodland. The layout here in the late woodland, I keep talking about it being a circular community with a central open area, but remember, there's that recent sedimentation that buries the northern part of that community a little more deeply than the others, so it was harder to detect features. The magnetic signatures were weaker over there. Here are those anomalies, the cultural anomalies over the surface collected data, so we've got a pretty good match there. And we can even play statistical games with the magnetic radiometry data. So we can say, well, there are really only 2 or 3 hot spots, even though there is a continuous distribution of magnetic features. And here in the late woodland, well, we see that northern area is obscured by that recent sedimentation. So all this data is digital, and you can play any number of wonderful games with the magnetic data, just as you can with the surface collected data too. So, all right, let's zero in on that middle woodland, that Havana community. So this is that eastern end of the site. These are the hundreds of anomalies, cultural features that were detected in what seemed to be an oval. Here are the most pronounced of those, so we still get that, but maybe there is a cluster here, individual households, possibly so. This is a model of middle woodland community patterning as summarized by Bruce Smith 25 years ago. So is this a permanent year-round village that's then associated with these other types of sites? That's the model that all of these people had suggested existed in Hopewell among all these areas, but none of these people had ever actually documented a site like this. That's why there's a big question mark right in the middle of it. All right? There is no documented permanent year-round Hopewell village that's been excavated. All of these types of sites have been found. Okay, well, what about model B? What if instead of permanent year-round villages, there were farming hamlets of 2 or 3 homesteads in the growing season, maybe occupied seasonally, with these other short-term camps associated with it, and then they disperse into cold season homesteads in more sheltered areas. And that's been documented not only in the American Bottom, but in many, many other areas too. This is a documented, Plan B does work. This model does seem to hold and is documented. And Plan C, the dispersed year-round farmsteads, does seem to hold for Ohio as well. Despite all those mega monumental earthworks in Ohio, there's no villages, but instead there are these dispersed year-round farmsteads. Okay. Well, this Model B is nicely documented in Illinois, Lower Illinois River Valley at the Smiling Dan site. So here are 3 homesteads around a gully. They use the gully for trash, which everyone in Illinois and Iowa still does. And in the American Bottom region, this is one of the better documented Hopewell Middle Woodland sites with maybe 3 or 4 homesteads, and maybe arranged in kind of a circle, but not necessarily all occupied at the same time. And all of these are much smaller than Gast Farm. We've got 140 by 120 meter. But you see the importance now of refining the dating of that site. Just based on the tiny excavated area that we have, we've got a spread of dates, repeated occupation over many years throughout the middle woodland, or not. Now, late woodland, the western end, again, very clear to me, I hope it's clear to you, distribution of cultural features. All these diagonal marks, by the way, that's when the site was occasionally chisel plowed. You're supposed to chisel plow at a 15-degree angle to the way that you normally plow, so that's exactly what's going on here. And here are the most distinctive late woodland features. So we have a central open plaza. We have the north area kind of obscured, but it is a good circular community. We call it a ring midden community, about 100 meters in diameter. And one of the best analogs, one of the most completed completely excavated analogs from right around this time period is this Millville site in southwestern Wisconsin, right around 300 AD, 3 to 400 AD. A whole series of single post dwellings, small dwellings, closely spaced, surrounding an open plaza with some communal features probably in the middle. All right, so those are the two communities. What about the mounds? Okay, just in case you can't see them. There they are. This big one we think is the 100-foot diameter mound. They said 10 feet tall, maybe, maybe not. But our friends at the National Park Service have looked at the magnetic data a lot more carefully to see if they could discern some of the internal features that might still be preserved even though the mounds have been flattened. And it does appear that there might be some remnant preservation of the internal structure of these mounds. Now, how is that possible in a flattened mound? Well, at the top you have a model of a mound with a central tomb, say, and it's filled with highly magnetic soil, topsoil, and then there's subsoil placed over that, and then another layer of highly magnetic soil, another layer, etc. And when that's flattened out, you get low, high magnetism here, low, high, low, high, low, high, low, etc. And this is one interpretation of how you could get a signature of high, low, high, low, high magnification, magnetism through a flattened mound. So magnetic radiometry might actually be a useful way of detecting flattened mounds for this reason. So once again, here's how they look according to our interpretation. You might have a double mound here. And here's how it compares to one of the recent magnetic surveys of a mound in the lower Illinois River Valley, Hopewell Mound at the Camp Mound site. Internal structure, pretty easily discernible here. And these mounds still stand, they're not plowed flat. So we kind of know what we're looking at here. And so there may be some similarities. The ones at Gast Farm might not be quite as complex, but we know they're from the exact same time period, and they might have a similar structure to them as well. The structure that's indicated here includes ramps and central tombs and a variety of reconstruction episodes. Now, recently my student, Alex Flores, who took a GIS class, I took a GIS class once and in 3 months promptly forgot it. But she decided to look at this mound data and try to figure out a number of things. For example, what was the height of these mounds? And she didn't know that locals had said that the big mound was 10 feet high. So she looked at other evidence from eastern Iowa of mounds that are still in existence that haven't been badly disturbed. And based on the diameters of those mounds, tried to estimate the height, based on the diameters and heights of those mounds, estimated the heights of these. And these all, according to her work, ranged probably from 1 meter up to 2 meters or slightly above 2 meters in elevation. And then she used the magic of GIS to estimate the volume of fill that these mounds consisted of, that comprised these mounds. And it totaled 833 cubic meters of fill. Well, if you spread 833 cubic meters of light-colored fill, we know it was light-colored, across the surface of the site at an average depth of 25 centimeters, you cover 2.1 hectares. And 2.1 hectares is just about the amount of ground that's covered by these white streaks here. So it supports my hypothesis. You never confirm a hypothesis like this, but it supports my hypothesis that these mounds were essentially leveled and their fill displaced long before Dan Gast ever took ownership of the property in the 1940s, 1930s. And these mounds, the fill of these mounds was then spread this way and this way and this way, and then continued to be spread by the plowing at this site, which has always been either in one of the cardinal directions. So I think, kind of unfortunately, we've debunked the earthworks hypothesis. And even though this kind of redeemed Alex Flores' work, my student, who spent a whole summer researching earthworks and trying to figure out what kind of earthworks these were. And then after she took her GIS class, she helped prove that these weren't earthworks at all. but helped, I think, document what might have happened to those 7 mounds. So I think we've learned a little bit about the 2 communities at the site, about the ritual and ceremonial work that was done there, as well as the domestic work. So right now we're looking at satellite imagery, such as in the lower left, where you see the 2 communities very nicely expressed, the west end, the east end, the mound here, and even the chisel-plowed scars heading in a diagonal direction. We've flown drones over the site last year, and we're doing photogrammetry as well as thermal imaging, and we're beginning to get some material worked up for publication. So the work is continuing, but I think we've made some pretty substantial progress over the past couple of years. So I want to be sure to thank all of the supporters of this work, the National Geographic Society, everybody listed here, especially my students down here and the property owners who have been enthusiastic supporters of our work. I think it's time to quit, and I'll be happy to address any questions that you might have. Thanks.